Sorry guys, by mistake I turned the iPad off. Okay, so that question was, I was about to explain what a kite is. So we have this kind of shape. Okay, and specifically this was the same as this, and these two were congruent. And yeah, so what a kite is, it's got no pair of parallel sides, okay, and it has two pairs of congruent sides, but not all four sides the same. Okay, otherwise it would make a rhombus. So a kite is no pairs of parallel sides and two pairs of congruent sides where not all four of them are the same as each other. So that's what a kite is. And then we're going to have a whole section on kites in this IXL. Okay, so let's move on to N3. N3 is classifying quadrilaterals. Is a kite always a quadrilateral? So what you want to ask yourself is, what does it take to be a quadrilateral? And it's pretty basic. All you need to be a quadrilateral is you need four sides. So now you ask yourself, does a kite always have four sides? And the answer is yes. Okay, is a rectangle always a square? Okay, so what does it take to be a square? We need all four sides to be congruent and all four angles to be 90 degrees. Does a rectangle satisfy those things? No, it doesn't, because it doesn't require that all four sides are congruent. So that's a no. All right, is a trapezoid always a quadrilateral? What does it take to be a quadrilateral? You need four sides to be congruent. And I'm sorry, you just have to have four sides. So yeah, a trapezoid has four sides. Okay, is a parallelogram always a square? To be a square, you need to have all four sides congruent and all four angles to be 90, but parallelograms don't necessarily have that. So this is a no. Okay, let's move up a level. So this says, choose the word that makes this sentence true. A trapezoid is always, sometimes, or never a quadrilateral. Okay, so what does it take to be a trapezoid? To be a trapezoid, you have to have four sides, first of all. The reason I jumped to that property is because that's what we're comparing it to on the right there. It says a quadrilateral. So I know that a quadrilateral, the only thing you need to be a quadrilateral is that you have four sides. And a trapezoid always has four sides. So it's always a quadrilateral. Okay. So a square is always, sometimes, or never a rectangle. Okay, what does it take to be a square? To be a square, you need to have all four sides congruent and all four angles to be 90. Now, rectangles don't have to have that property. They could have that property, but they don't have to. So this is sometimes. Okay? Rectangles don't always look like squares, but if you shrink it enough, then it'll end up that all four sides are the same. So in that one case, it would actually be a square. So sometimes they're squares. Whoops. I got that backwards. Oh. Yeah. Okay. So, yeah, these get confusing sometimes. Okay, so I was looking at it backwards. So I should have asked myself, what does it take to be a rectangle? And what it takes to be a rectangle is you need all four angles to be 90 and opposite pairs of sides to be congruent. And squares definitely have that. All four angles are 90 and opposite pairs of sides are congruent. In fact, they're all congruent to each other. So this should have been always. A square is always a rectangle. Okay, is a rhombus always a rectangle? So what does it take to be a rectangle? You need one of the things you need is all four angles to be 90, but rhombuses don't always have all four angles 90. So this is no. Choose the word that makes this sentence true. So it says, a kite is always, sometimes, or never a quadrilateral. Okay. A kite is always a quadrilateral because a kite has to have four sides. So this is always. A quadrilateral is always, sometimes, or never a rectangle. Sometimes quadrilaterals are rectangles. A rhombus is always, sometimes, or never a quadrilateral. So all it takes to be a quadrilateral is that you have four sides. So this is yes, a rhombus always has four sides. Does a rectangle always have four congruent sides? The answer is no, not always. So we can forget about the option always. Oh, I can't unclick it unless I click another one. Okay, so it's not always. Let's think of sometimes. Is sometimes a rectangle the same as a rhombus? Yes. Sometimes it could be a rhombus if all four of its sides are congruent. Okay. A parallelogram is sometimes, always, or never a rectangle. Sometimes it's a rectangle. All right, let's go to N4. All right, so we need to find missing angles of a parallelogram. Okay, so one of the properties of a parallelogram, well, actually, let's talk about a basic quadrilateral first. So any quadrilateral has the following property. All four of its angles, that's not very clear drawing. Let's draw another one. Smaller. So we got, okay, so all four of its angles have to add up to 360 degrees, unlike a triangle, which adds up to 180. Now, there's certain properties, though, about parallelograms that lets us answer this question. Because if they have told us that a quadrilateral has one angle measure of 55 degrees, there's no way we would have been able to figure out the other ones. But since they're telling us it's a parallelogram, there's special properties about parallelograms that's going to let us figure out all of the angles. Okay, so let's draw a parallelogram. So we got this parallelogram right here. And let's say we know one of the angles is 55. Okay, well, let's not do that one because that one's obviously an obtuse angle. So let's say that this one down here is the one that's 55 because it's actually acute. So one of the properties of parallelogram is that opposite sides are congruent. So if that's 55, then this is also 55. And then another property is that consecutive angles are supplementary. So what that means is that if you take these two angles that are actually right next to each other, as opposed to opposite, they have to add up to 180. So if you want to figure out the green colored angle, you would do 180 minus 55, which is 125 degrees. So this is 125, and then this one's diagonally across, or opposite, I mean. So this is also 125. Okay, so we got 55, 125, and 125 are the four angles, are the four interior angles of this parallelogram. Okay, let's go jump up a level. All right, two angles of a quadrilateral measure 60 and 250. The other two angles are in a ratio of 2 to 3. What are the measures of those two angles? Oh, I didn't see this question coming. Okay. All right, so we know that two of the angles are 60 and 250. So at the moment, that is a sum of 310, which leaves how many left over for the other two? Well, the total is 360. So if we do 360 minus 310, that leaves us with 50 degrees left between the last two angles. Now, at the moment, as far as I've read, which is up to here, that's not enough information to determine it, because it could be like 40 plus 10 could be the last two, or it could be 25 plus 25 could be the remaining two. Both of these things add up to 50. So at the moment, we can't tell what it is. But when you continue reading the question, it goes on to say the other two angles are in a ratio of 2 to 3. Okay. So that means that so let's recall something about ratios. So we got this ratio 2 to 3. Another ratio we can write from this one is that we have a ratio of 2 to the total of 5. And we can also write a ratio of 3 to the total 5. Okay, and you get the 5 just from adding these two together. So just like if you had a ratio of 2 boys to 3 girls, then you could say that's a ratio, that implies that there's a ratio of 2 boys to just 5 children total. Okay, and the 5 comes from adding these two, 2 and 3. Okay, so let's erase this boy-girl stuff. Okay, so we can say that there's a ratio of 2 to 5 where the total is 50 though. So in our case, the total left over is 50. So for one of the angles, we can say that it is 2/5 of 50. And for the other angle, we can say it's 3/5 of the total 50. So remember that when you get a ratio, you can just write it as a fraction. Okay, so if we go ahead and we multiply these two, we're going to get 2 over 5 times 50 over 1, And this, you just multiply straight across, so we're going to get 100 divided by 5, which is going to be 20. And then if we do this one, 3 over 5 times 50 over 1, multiply across is 150 over 5, which is 30. So we get 20 and 30 degrees is what the last two angles are going to be. Okay. So this will be 20, this will be 30. Done. Delete screenshot. Let's plug it in. 20 and 30. Submit. Okay, close. Okay, I didn't see these questions. When I went through, I didn't see all this ratio stuff. Whatever. Reviewing ratios, I guess. Should I do another one? I feel like this one's kind of the same. You're going to add 270 plus 25. You're going to get 295. There's going to be something left over, which is going to be 65 degrees. And then the other two angles in a ratio of 4 to 9. You're going to do the total. So you're going to do 4 out of 13 and 9 out of 13 out of the remaining 65 degrees. And then you're going to do the same multiplication. So it's basically exactly the same steps. I think you'll be able to follow it. Let's jump up a level to a different question. Same kind of question. And really? Okay. Parallelogram. Yeah, I'm surprised there isn't anything about like square or kite or rhombus. Okay. Let's go to M5. Okay, N5, graph quadrilaterals. All right, so this one's asking us to graph quadrilateral with vertices -6, -2, 9, 2, -4, 1, and -5, 5. I'm not going to do this one. All you have to do is find those coordinates. What I will say is that you want to do them in order. Because if you don't do them in order, like let's say we do -6, comma -2 first. Whoops, not there. Right there. And then let's say you skip over to -4, 1. -4, 1 is right here. And then you go back and do 9, 2. 9, 2. And then you go do -5, 5. -5, 5. Oh. That worked out perfectly. I thought there was a possibility of like having something like this happen, which you wouldn't do. Okay, your drawing cannot come out like this. Okay, I forget what this is called, but it shouldn't come out like this. None of the lines should cross over each other. Okay. So that's all I'm going to say about this particular question. Let's jump up a level, see if it gets any different, any harder. Yeah. So it gives you 3 vertices of a rhombus. Okay, so let's go to -7, 9 is up here. -2, 9 is right here. -5. Okay, so this line that we've drawn so far should already be a hint to you. Because the other side has to be parallel to it. Because a rhombus is a parallelogram. Okay. So the other line, the opposite side is probably going to be underneath this one. So let's go ahead and graph the next. We got -5, 5, which is -5, 5 is right here. And then it says we need to complete the rhombus. Well, the rhombus has to have the same opposite sides, the same length. So if you look at the top line, it has a length of 5 units, right? It goes from an x-coordinate of -2 all the way to the left, an x-coordinate of -7. That's 5 long. So the bottom, the opposite side has to have also length 5. So it would have to be here. at this point. So let me just take a picture. Actually, let's just go back a step. Is there an undo button? I think I just click this. Okay, let's start from here. So we would have to choose a point out here far enough so that it has the same distance as from here to here, which is 5 units. So we have to go 1, 2, 3, 4, 5 out to this point here. And then that means that this length down here, which I'm doing in red, is the same as up here, the one that was up here. That's what we need. And then it turns out that the other one just kind of works out on its own. Okay. Delete screenshot. I'd put it there. Submit. Whoops. Mess that up. Okay, this one's a rectangle. Okay, so -7, 2, 6, 2. That's a very small side. And 6, 9. 6, 9. What am I doing? Oh, 6, 2. Oh, brother. Okay, 6, 2 is over here. Okay, it's actually a really long side. And then 6, 9 is up here. Okay, so if we wanted to complete this rectangle, we can't put the last vertice like over here, or over here, or over here. Okay, it has to be in a way so that we make a 90-degree angle. So we have to bring this up all the way in this direction. Like that. Okay, submit. Parallelogram. This is a good one. So we got 5, -7. 5, -7 is right here. 8, -7 is right here. 5, -8. 5, -8 is right here. Graph the parallelogram. All right, so let's do this in a picture. So let's zoom in. For this to be a parallelogram, let's compare it to this side right here. It's 3 units long. Its opposite side, which is not this one. It's the next side that we draw on the bottom. This side, it has to be 3 units long. So we're gonna go 1, 2, 3. Okay, so we're gonna put a vertex there at 2, -8. And then if you notice, that's all 4 vertices, right? We got one vertex here, another one here, and a third one there. We only needed one more to create the parallelogram. So it goes there, and then you just connect the dots. So let's see if we can pick this light blue. Like that. Okay, so delete screenshot. The 4th point has to be at 2, -8, which is right there. And then you can just check, you know, that's 3 units long. The top part is 3 units long. And like so it's easy to tell that this is 3 units long and this is 3 units long. For these diagonal ones, you can't just count like 1, 2, 3. You can't just do that. You really need to sort of do like kind of like the rise over the run. So we're gonna go 1, 2, 3 to the right, and then up 1. And you want to check that the same thing happens between the points defining the opposite side. So 1, 2, 3, up 1. Okay, and it makes sense that the slope here is 1/3 and the slope here is 1/3 because it's a parallelogram, and these two sides, well, these two sides have to be parallel to each other. So you can, maybe that could be running through your mind while you do these also. Okay, I think that's okay. Let's do N6. Properties of parallelograms. Okay. So, one of the properties of parallelograms is that opposite sides are congruent. So, that means that the side labeled 3W has to be equal in length to the side labeled W plus 36. And they're asking for the value of W. Well, we have a relationship between these two expressions. The expression is that they're equal to each other. 3W should be the same thing as W plus 36. So we're going to figure out what W works. Okay? So if you didn't remember how to do algebra, you would plug in a bunch of numbers, try to figure out what would work here. I really don't know. I think it's, nope, 18? I think it's 18. So if you didn't know how to do the algebra, you would try to find numbers that work. So if you plugged in 18 here, whoops. Now, I'm not advocating this. I will show how to do it with algebra. I'm just reminding you of what it is that we're trying to do here. So 18 times 3, I think, is 54. So this is 54, and 18 plus 36 is 54. So 18 works, so the answer would be 18. But let's do it with algebra, which is what you should do. Plus, I did that really quick. Some of you are going to try to do that, and it's going to take you forever. So let's, this is the whole point of algebra, is to make this process more methodical so that we're not sort of guessing and choosing numbers. Okay, so in this case, we have W's on both sides. We need to combine them together. The way we do that is we're going to subtract. I like to subtract the smaller one, so this cancels out, but we got to subtract it on the other side. So we get 2W equals 36, and then we can divide by 2. This cancels out, divide by 2, and we get W equals 18. Nice methodical way of doing it. Okay, delete screenshot. W is 18, submit. Well done. Okay, find the value of Y in a rhombus. Okay, so there must be some relationship between this angle and this angle. Now, I didn't say anything about a rhombus specifically, but I did show you a property of parallelograms. And one of the things I said about parallelograms was that consecutive angles are supplementary, so they have to add up to 180. Now, this is also true for a rhombus, because a rhombus is a parallelogram. Okay? A rhombus is a parallelogram because this side is parallel to this side, and this side over here is parallel to this side over here. So a rhombus is a type of parallelogram. Okay? It just so happens that all four sides happen to be congruent. So, although this is a rhombus, we can still apply the fact about parallelograms to it. So let's get rid of some of this stuff here. So we're going to be allowed to say that those two angles, angle S and angle P, have to add up to 180. Okay, so we have a relationship between the two angles. We have that angle S plus angle P has to be 180. And forgive me for not putting the M's here. Measure of angle. Okay, now, measure of angle S, we have an expression for it. It's Y. And measure of angle P, we have an expression for it. And that is Y plus 76. And this has to be equal to 180. Okay, So we're going to combine like terms. So we're going to get y plus y is 2y, and we still have the 76 lingering here. Okay, and then we're going to subtract. We have to isolate the y. We have to subtract the 76 first. Subtract 76. So we get 2y equals 104. And then divide by 2, this cancels out, and we get 52 degrees. Well, sorry, y is 52. They even put the degree symbol here. I won't worry about that, that's fine. 52. Yeah, it is degrees. Sometimes these don't actually represent. I'm not sure actually. Anyways, it's 52. Done. Delete. Let's plug it in, make sure. 52, submit. Uh-oh. Okay, good. All right, parallelogram. So find the value of y in parallelogram TUVW. There must be some relationship between those two sides that are labeled, and the relationship is that they're congruent to each other. So remember, parallelograms imply a couple things. Not only does it mean that opposite sides are parallel, they point in the same direction, but the other thing that you can take away from when someone tells you a quadrilateral is a parallelogram is that the opposite sides have to be congruent. So this side has to be the same as this side, and this side has to be the same length as this side. Okay, so the relationship between those two sides is that they're congruent to each other. So we can say that the side, well, let's do it like this. WT is congruent to VU, which implies that 4y has to be equal to y plus 12. Okay, so then we got to solve for y. Unfortunately, there's y's on both sides, so we're going to have to move one over. We're going to subtract y here, subtract y. This cancels out, and we get 3y equals 12. And then divide by 3, y equals 4. Okay, so y is 4. Done, delete, plug in 4, submit. Okay, let's see if we have anything harder than this. Same stuff. Any harder? Same kind of thing. Okay, this is a good one. Although I don't know if I'm going to make you go this far up in score, but whatever, we'll do it anyways. Yeah, so the other thing I said about the angles of a parallelogram is not only is this angle and this angle supposed to add up to 180, but we also said that opposite angles are congruent. So this angle is actually the same as this one for parallelograms. And remember, if that's true for parallelograms, then it's also true for rhombuses, it's also true for rectangles, it's also true for squares, because all of these are parallelograms. Okay, but anyways, in this one we just have a parallelogram. So okay, so those two expressions have to be equal to each other. So okay, those two angles. So yeah, let's do this the right way. Angle V is congruent to angle T, which implies that the measures of the angles have to be equal. Remember, the measure is an actual number. So the measure means a number, which is why we get to use the equal sign here. Equals is for numbers. Just the object, the angle, that's like an object. So we don't use the equal sign. We use the congruent symbol. Okay. Just nitpicking. Okay, so measure of angle V is associated with this expression, Z plus 44, let's put a little thing, equals 3Z minus 92. Okay, so we have z's on both sides. We're going to have to subtract z here, subtract z. This cancels out. We got 44 equals 2z minus 92. Add 92, add 92. We get 2z equals 136. And then divide by 2. This cancels out. Divide by 2. And we get z equals 68. Done. Delete. Ooh. Hold up.